Okay, hi everybody. Thanks for joining me this afternoon. I'm going to start off with uh, a quick little slide presentation, just describing some of the background and motivations behind the Alberta Water Tool, and then I'll jump into a demo to demonstrate how to use the tool, and then I'll open things up for some questions at the end. It should take about half an hour. There should be a chat window in YouTube that you can add any questions in there as we go along, and then I'll just try and answer those as best as I can once we get to the end. So the Alberta Tool, what is it? It's a rapid, cost-effective support for water resource management decision making. It's a web-based tool that provides accurate real-time information on surface water resources, existing water allocations, and the needs of the natural environment. And it lets you access this information at more than 180,000 unique locations in Western Alberta. And so the watersheds, essentially, each time you move down the stream, once you go past another tributary, then the watershed will change and you'll get a different report based on the licensees and the hydrology of those areas. So it covers about 140,000 square kilometers of Western Alberta. So it's bounded at the north by the Peace River and goes east along the Peace, just about to the town of Peace River itself. And then it's a swath that goes southeast from there, parallel to the Rocky Mountains. And this kind of area was initially chosen as it overlaps with the play fairways for the Montney and Duvernay. And the first version of the engine that drives the Alberta Water Tool was built in 2012 for the BC Oil and Gas Commission. That's NUT, or the Northeast Water Tool. And since then, we've continued to kind of grow and expand on the methods and the technology across a good chunk of the remainder of BC and in Alberta here. The hydrology modeling that's incorporated in the tool comes from the Integrated Assessment of West Central Alberta project, which was an OPERF and PTAC initiative that ran from 2012 to 2014. So that brought together kind of under PTAC's sponsorship, supported by CAP. There was 12 oil and gas producers that contributed to that effort, and that project itself looked at surface water, non-saline groundwater, and saline groundwater resources. And the Alberta Tool is essentially a decision support tool that's based on the results from the surface water component of that project. So the technology itself, so that's the actual web interface and all the supporting technology that makes it work, was developed by Foundry Spatial with the support of the National Research Council Industrial Research Assistance Program, and through Techterra, which is an Alberta-focused geomatics accelerator. And as of September 14th, thanks to the support of OPERF, PTAC, and CAP, the Alberta Water Tool is now open access. So it's available to anybody in the world at alberta-watertool.com. So the benefits of the tool is that it gets you up to speed really quickly on what the hydrology of a region looks like, and also what the supply and demand picture looks like there. So it provides very detailed information about water supply and demand. It's both accurate and scientifically rigorous. And ultimately, the purpose of these tools are to save people time and save people money, and also to result in better environmental outcomes. Historically, to produce the type of information that's generated in the tool is pretty labor-intensive process. And what that means in the real world is that sometimes decisions aren't always made with a consideration of all the information that's available, strictly due to limited resources and limited time. So within the tool, the web interface allows you to produce reports for individual watersheds. And those reports include information on the long-term average seasonal water supply. So that's the timing and volume of runoff over the course of the year. The surface and groundwater allocation amounts. So all the active long-term licenses and temporary diversion licenses in Alberta are contained within the Alberta Water Tool, and those are updated on an ongoing basis. It provides information on sustainable lake withdrawal limits based on an accepted practice from Alberta Environment and Parks. It provides information on the environmental flow needs of those streams, lakes, and rivers using the Alberta desktop method. And it combines all that previous information into what is identified as a remaining potential allocation within those EFN, or environmental flow needs, thresholds. In addition to that hydrology and water use focused information, it also provides a description of the physical characteristics of the watershed. So that's the land cover makeup, the superficial geology, the terrain, also information on what the current or historical climate is like there. So what the temperatures look like over the course of the year, precipitation over the course of the year, and snowfall. And managing water into the future in a changing climate is something that everybody's concerned about these days. So rather than create a predictive hydrologic model, what we show in the report is what the future climate prediction looks like. So you have essentially what the climate used to be like in a watershed, and then we present what the future climate, how the future climate might differ. So which months might be warmer, which months might have more or less precipitation, and how the amount of precipitation that's falling as snow might change. So the model that drives the Alberta Water Tool, as I mentioned earlier, was produced through this Integrated Assessment of Water Resources project. And the goal from the outset of that project was to end up with a tool like the Alberta Water Tool. So the modeling that was conducted through that project was crafted to support the needs in terms of the resolution, the geographic resolution. And it was also crafted to support the needs of the environmental policy in Alberta. So we're producing annual and weekly runoff estimates across the region, and parameters required to calculate the environmental flow needs. And the model incorporates 106 long-term hydrometric data records distributed across the region. And the model performance is, we have 3 statistics that we typically use as metrics. So there's the mean error. This relates the error, or the predicted runoff in those gauged watersheds against the measured in those gauged watersheds. So out of those 106, the average error was 2.6%. The median error was just below 0 there, and 76% of those 106 hydrometric stations, the model was within plus or minus 20%. So that's very good performance. Those statistics are all cross-validated within the model, and it's approximately the same as the model performance within the Northeast Water Tool. So just a quick overview of the policies that are applied. The Alberta desktop method for determining environmental flows. It's essentially a threshold of 15% withdrawal up to the 80% exceedance flows. So that logic is applied to the model data within the tool and ends up producing what the acceptable allocation amounts are. If you click on the tool on a lake, you'll get an additional page in the report that gives you the results of an accepted practice from Alberta Environment and Parks, which is essentially a 3-pronged estimate of an acceptable withdrawal volume. and that it combines sort of a water balance approach with a lake level drawdown, and then a maximum threshold for any applications that can be considered using that method. And all of these policies that are applied within the tool can be updated as policies evolve. The framework's really flexible in terms of providing the information required to help support decisions. So these tools that we've built have been recognized substantially, primarily in BC and also further afield. So the original Northeast Water Tool won a Premier's Award in 2012, 2013 in BC. The contributions to sustainable water management were recognized by APIG BC in 2014, and also an Environmental Innovation Award at the Global Petroleum Show in 2015. And then the Alberta Water Tool itself was an Innovative Excellence finalist in 2016 at the Biotech Awards. I just have a quote here from Alan Chapman, the former Senior Water Resource Specialist at the Oil and Gas Commission. He says, "The Alberta Water Tool is unlike anything else in North America. It's revolutionary and tremendously valuable," which I hope you find as you use it. So on that note, I'll jump right in to a quick demo here. I'll just wait and make sure my screen gets where I'm trying to get it here. Okay, so here we have the home page of the Alberta Water Tool. So this is what you see when you go to alberta-watertool.com. So it's just a stripped down version of the website here, just providing some basic introductory information in terms of what it is, some of the features and benefits, and links to the background information like the data that drives the model. And then just click on the blue button over on the left-hand side or up in the top right corner, and that'll bring you right into the tool itself. So within the Alberta Water Tool, there's two halves to the application. One is watershed reports. So this lets you produce a custom PDF report describing the hydrology and the other characteristics that I went over in my presentation there. And then the other section is streamflow data. So all of the historical and current active hydrometric stations in Alberta are in here. The circles represent clusters of stations. So rather than overwhelming with with hundreds of points on the map, they get clustered, and then the bands around the outside correspond to the colors in the legend. So out of these 75 stations in eastern Alberta, just over half of them would be discontinued. About a sixth would be active and either non-real-time or real-time and not responding. And then just about a third would be active, real-time, and responding. So you can just use your mouse wheel to scroll in and out, or click on these clusters and you'll zoom in. And as you get closer in, you'll start to see them expand into individual map markers. You also see the map base change. So you'll get more place names, more stream names as you zoom in. You also see the township and range grid appear with labels as well too as you get in even closer. So I'll just click on one of the hydrometric gauges in the region here. So to click on the map marker, you get some overview information about the station itself. And then you click on the chart button, and that'll take you into a chart showing you the 7-day flow, the historical data for that gauge, and then overlaying on top is, in this blue line here, is this year's current conditions. So you can see that that flows are quite low through the start of September, and then last week there would have been some rain around Valley View, and flows popped up again. You can overlay individual historical years on here. So if there's a specific year that's kind of a reference year that you're interested in relating what this year might look like in relation to that, you can do that. You can add up to 3 of those at a time. Using your scroll wheel on your mouse, you can also zoom in on the chart. So when you get down to low flow times, it can sometimes be hard to see what's actually happening. So you can zoom in and then just click and drag them out, or drag the chart around to pan to a different area. Hit the button here to reset it, or just use your mouse wheel and scroll out. You can also download the chart from this view, and that'll just download a PNG file to your computer, which you can then use to put in a report or do whatever you need to do. All of the stations are presented on the map by default. You can also use the filters to refine those stations based on if you're looking for something in particular. So if you want a continuous stream flow gauge, so there'd be one that operates year-round, you can choose that. And also restrict these to only active, real-time, and responding if you're interested in what's happening currently out there. You could also apply a date range. So if you're only looking for long-term stations, you could do that in here. Or if you're only interested in data, that's recent, you could also set a minimum year threshold of 2005 or something, and also only see monitoring that's occurred since then. The other half of this filter window gives you the listing of the stations. So these are the ones that are in your filter, and they're also visible on the map here. You can compare these just by hitting the compare button. That'll add those to this this little snack bar window at the bottom. And when you hit compare in that little window, it'll plot those stations that you selected in the same window. And again, you can download these directly from there. So that's kind of it for the monitoring data. I'll just switch over here and have a quick run through the watershed reports. So again, it's a similar presentation at the start. You'll see here that we don't have access to the whole of Alberta because we haven't done modeling for all of Alberta. It's just this 140,000 square kilometer section of Western Alberta. And the rest is grayed out. The circles again represent clusters of locations, except instead of being monitoring locations, these are the current active licenses in the region. And again, the band around the outside of the cluster tells you what is in that cluster, or the proportion within that cluster. So in this 121 cluster, there would be 1/3 of those would be short-term surface water, 1/3 of those would be long-term groundwater, and 1/3 of those would be long-term surface water licenses. And same idea, as you zoom in, these will expand into individual map markers, and you can click on those and get information on who holds the license number as a reference if you want to pull the original file, the source, the volume, the purpose, the priority date, and the status. So that's the status and the effective date. Now, to actually produce a report, all you have to do is take your mouse and click at the location that you're interested in. So what that does is pretty much instantaneously defines the watershed associated with that location. So it clicked on the Smoky River there, tells you how big the watershed is at that point. It gives you the latitude and longitude of the location that you clicked. And then there's this button here that'll produce the report. So you can either proceed in just navigating to where you are, maybe looking at the township and range grid and finding that specific location that you're interested in. Or you can also add coordinates directly in over here, and that'll produce the same result. So we'll just enter these same coordinates as we did for the Smoky River. There you go, and that did the same thing. So we'll just click a little further upstream there, and then we'll produce a report. So it takes about 5 or 10 seconds. And then the report downloads to your computer. And then we'll just click on this and open it up. And then this is the presentation quality report that you get for that location. So the first page starts off just with a map of where you are, where you clicked, and the watershed associated with that point. It gives you the locations, the watershed area, the range of elevation in the watershed. It also lets you know which river basin you're in. So this is these are reference from a planning perspective. There's a page as an introduction. So for people who maybe haven't seen one of these before, it gives an idea of how it was produced, where it came from, and there's my contact information on there if anybody has any questions. And then we get into the more technical information. So we start off with an overview. So what the predicted mean annual discharge is, the annual surface water and groundwater allocations presented as a rate of withdrawal, the sustainable withdrawal limit. So that's the results of the EFN calculations. And then the current allocations expressed as a percentage as well. So you can see on the Smoky River at this point, the sustainable withdrawal limit would be about 13.5% of the mean annual flow. And the current allocations are at 0.5%. So the remaining potential allocations between those two numbers would be about close to 20 cubic meters per second, or about 627 million cubic meters per year. Below, we get into just some background again, emphasizing that these numbers are estimates of long-term averages and generated by a model, that there's error associated with all the inputs to that model, and as it's a long-term estimate, it doesn't necessarily represent what's happening out there today. And there's a similar set of disclaimers on the allocations that are included as well too. There's limitations in terms of how that data is presented and the conclusions we can draw from it. And there's also potential for errors to exist within that data. The next page provides kind of the meat of the report. So on the left is a weekly hydrograph, and then on the right-hand side is a table representing the values that are shown on that chart. So for week 1 to 52, we have what the predicted mean discharge is, the allocations, and then how much flow is remaining. And then there's also the EFN requirements. Moving on, we have get into the information on the allocations. So again, just present a high-level summary at the start. So the primary water use in this watershed is oil and gas. And right now it's mostly being sourced from surface water. It's about 20 million cubic meters per year of surface water, less than 1 million of groundwater. And oil and gas is by far the dominant water user in the watershed. Subsequent to that, there's a listing of all the allocations within that watershed. Again, presenting the same type of information that was on that pop-up in the app. So the licensee, the purpose and source, the license number, priority date, which the table is sorted by, as indicated by this little arrow here, the quantity, and the status. And then the largest licenses in the watershed are highlighted on these pages, just to kind of draw your attention to the major water users. So there's going to be about 15 or so of these in this watershed. I picked a bigger one, so the number of allocation pages is obviously variable based on how many licenses there are active in the watershed. Once you get through all of those, just at the bottom of the allocation pages as well too, it tells you how current the data is for the licenses. So for the Alberta database, those water licenses are current as of September 11th, and in BC, those are current as of today. Following that, we get into the physical description of the watershed. So the land cover composition, so it's predominantly coniferous forest in the Smoky River watershed. The second biggest category would be mixed, so that's a mixed deciduous coniferous forest. And then up in the headwaters, up in the mountains, there'd be some barren and shrub areas. Likewise, superficial geology. So the watershed's dominated by colluvium and morainal deposits. And the climate page. So this is, I touched on this briefly in the slide presentation. We have the dark solid line is the historical normal. So that's the 1971 to 2000 estimate for average monthly temperature, precipitation, and precipitation as snow in the watershed. And then those shaded bands represent what the potential future envelope of conditions looks like. So on the temperature side, there's consensus amongst those projections that it'll be warmer in the watershed. Sorry, I should just note that these projections are based on a range of potential futures. So with global circulation models, they have kind of emission scenarios. So these are potential, the window of what those estimates look like. On the precipitation, it's not quite so consistent. There's suggestion that in the first half of the year, there could be more precipitation, but then through the summer, there's the potential that in July, August, and September, there could be more or there could be less. So there's not really any clear assumptions that you could draw from this in this watershed, but in some other watersheds, it's much more significant in terms of what the potential impacts of climate change could be. And then on the snow as well too. Not surprisingly, with increased temperatures, less snow expected in the shoulder seasons in particular. But then in the wintertime, where the temperature increase would still be, you'd still be seeing freezing conditions, then that increase in precipitation would be an increase in snow. There's a page on the terrain characteristics. So this hypsometric curve is essentially a cumulative chart of the elevations within the watershed. So about 50% of the watershed is up above 1,500 meters. So it's a fairly high elevation watershed. This can provide some insight into the function of the watershed itself during the spring freshet, and also how consistent the impact of storms, for example, would be across the watershed in the summer. Getting towards the end of the report here, this water management basin. So this concept is to ensure that the impacts on downstream users are considered. So on the little map there, the blue dot or the blue marker represents the location where we clicked, and then the gray marker, which is not terribly far downstream in this case, but it generally goes down to the next major confluence. This presents what the mean annual discharge and sustainable withdrawal limits are at that location, and then also what the current allocation pressure is in that watershed, along with a listing of who the major users are there. So there's not much difference. The Milner Power and Grand Cache were the two biggest users in the, Grand Cache is a new one in this one, I think. But there was Milner Power and the town of Grand Cache, which were two of the bigger users in the upstream as well. And then finally at the end, there's just some pages on notes. So that's described all the data sources which are referenced in the report, and the model performance is included on the final page. And that takes us basically to the end of the presentation. A couple minutes over here. I haven't seen any comments or questions in the chat window. Though I'll hang on here for a couple minutes in case anybody has anything they want to put in there. And if not, feel free to get in touch with me at any time if you have any questions on anything about the tool, how it works, any of the data or models, anything. I'm happy to chat about that at any time. Yeah, and on that note, I don't see any questions, so I will let everybody go, and thank you for joining me, and yeah, hope you find the Alberta Water Tool useful. Enjoy the rest of your afternoon.